That would be cool, but I doubt I would have at that grid cell
Yeah,
resolution.
you need it at the
there.
grid size, week, whatever it is, whatever your unit to time as well.
But you could just use previous year's CPU, fleet-wide CPU week,
That's true. Yeah.
because everybody's gonna have an idea, you know, I mean, I think that the data are published at the end of the year, aren't they, at that scale?
Yeah.
So that's information they all have.
Okay. Yeah, that's interesting.
Yeah, you got to be careful with filling in values that are then quite good is the difficulty. So you don't want the fill-in values dominate things.
Yeah.
And it's and doing what you're doing, it's going to be better than half of the areas they fished, right? So
That was what I was saying.
right, so that's probably not a very good proxy.
Yeah.
Because they wouldn't, you know, because most of the areas they haven't fished are probably not places that there's any expectation of it being good.
Yeah. So yeah, I think I make an assumption that a new place will just be as good as the average area
Right.
they've been. They've probably been to good places more than bad places.
Yeah,
Yeah.
because they're using everything they know to avoid the bad places.
Exactly.
So you might just see if it makes a difference if you fill in the areas with the worst they would count.
Okay.
And then,
Yeah, I was trying to think, can you estimate the unknown CPUE, but I think that's probably unestimable.
well, it could be a weighted average of historical rates in each of those other cells.
I guess what I've done is, like before the start of the data that I'm using, I've had more historical data. And I've taken the mean of, the mean CPE for every year for every area. And then I fill that in, so it's, you know, historically every place that's been fished from like pre-2015 or whatever.
Oh, from like the very beginning.
Yeah.
I think my time series starts in 2000.
Okay.
And then get a mean for each individual cell. And then for the areas that have never been fished, I think I also used a mean, like a global mean, but that's probably wrong. So maybe do like a minimum, which was what I guess Ray was getting at. So,
Yeah, minima can do funny things too, because they're probably close to zero for some weird, you know.
but they should be close to zero.
Yeah, but if it's never been fished before, there's got to be a reason for that.
Yeah,
Is median or mean? Or does it really matter?
It should be very different.
Yeah, I don't think they're really spectacularly good sites.
I have a question, but I think it might be a dumb question.
Okay.
So when you're thinking about your CPUEs, so the fishery opens in mid-October and goes through it's early March, isn't it? Is when the fishery closes? Kind of,
I think-
should know this, but.
I think maybe the end of March, but typically, yeah, fishing just stops.
So are you looking at your CPUEs like through individual seasons and how much they change? Because I know as crab approach molting and mating periods, we think they stop going into crab pots. So I'm wondering if you would have a difference in your CPUs at the end of the season versus the beginning of the season. And snow crab I don't think they start fishing until January. Season opens in October.
Yeah, that's an interesting point. I kind of treat every single week as like equal to each other. So any like within season dynamics, I'm not really quite capturing in the model, but it is a good consideration.
But I mean, you're capturing within the dynamics because you're always looking back at the most recent 2 weeks. Right.
No,
Okay, so that is, yeah.
relative, so predictions are all relative within a week anyway.
Yeah.
So your absolute catch rate would be quite good.
Yeah, I was thinking, I had this idea of trying to standardize CPEs by TAC per season. I don't know how worthwhile.
I don't think that the TAC just tells you how long the season is, John.
Okay.
But that might affect your strategy for that week though.
I think so. Yeah.
Yeah.
Like I know that like a low TAC. They don't really care about fishing in those CPE areas, they'll just write it out. So it'll only take a few weeks to get to that, to their low quota. Okay, and then moving on to vessel density, I just have this as number of pots drawn by other crab vessels.
In the week before, or?
In the 2 weeks before, yeah. And risk, this is the CV of the CPE both at the vessel and fleet level. Costs, I just have this to distance to the port of landing, targeting percent retained crab from the observer coverage data, or the coverage is only 30%, so it's not great, but still is somewhat useful. And then for environment, I have ice cover, and there's some good resolution on this. There's a new ice shapefile every 2 weeks, so it's not too bad. So how I do this is I'm modeling how a single vessel chooses which grid cells draw this plots. And through a discrete choice model, which is just predicting one choice, almost a set of options.
I hope there's a log in there somewhere.
Oh, there's a log, yeah. Yeah.
If not, we got
I knew someone
bad.
was going to say something. But since there are many grid cells to choose from, it's just a regression model, and how a discrete choice model predicts preferences first by setting a utility or a value to each one of those little black boxes. There's first an intercept or kind of an area preference here, and then some covariate, and then the global parameters. Those covariates specific to that specific area. And how we predict that probability of making that area choice is just the exponentiated utility of that area divided by the sum of all exponentiated utilities of all areas. And to address that fleet-wide strategy, I'm using a fixed effect. So an area intercept for each of the grid cells, and then those global parameters of those covariates. And then to address the vessel diversity. So maybe each vessel has like a different area preference or responds differently to a certain covariate. I have random intercepts and random slopes. There's a whole model selection process. Choose the best one, find the right effect structure first, put it fixed. I'm going to give you diagnostics now so you can take my results with the right grain of salt. The next few slides. So the accuracy, this is just how many times or the percentage of times the model got the right grid cell area correct, and that's 24%. Among 30 areas, it's not awful, it's not really great. But also the tricky thing is I get this fish ticket data that was resolution of a week, and then within a week, fishers often make 2 to 4 areas. So there's really multiple right answers instead of one, which is what the discrete choice model is doing. So the maximum accuracy that this model can do is 42%. So if we normalize that, 24 divided by 42, 57%. That's kind of fuzzy math. I don't know if it's the statistical way to go about things, but it's at least better.
But when the accuracy is based on the highest catch cell within a week.
Yeah, the highest predicted probability or utility.
But the truth is, if you choose one cell for a week, what is the true cell? The one with the highest CPV of all the cells, the highest catch, I guess?
I keep them all in.
Ah.
Yeah.
You want to take me through that?
Yeah, so say like they spent even distribute their effort over like 2 areas.
Okay.
I just keep those 2 areas in the model. And I think it still fits to both of them. But I think, correct me if I'm wrong, but I think it tries to minimize like the difference. So it tries to keep those utilities 0.5.
Oh, so both. So there's 2 observations in the week.
And is there a reason you don't have the set-by-set data?
I don't know. I've asked multiple times. I just think this is as resolved as I can get it.
I mean, is that for confidentiality reasons, or?
I don't know.
Because I mean, I've got it for the Amendment 80 fleet. I got flat bomb on every toe. Yeah.
Who did you ask?
Cody.
Yeah, Ben
That's
Daly.
probably a Ben Daly question. That's
Yeah,
a data
okay.
question.
Yeah.
He has a form for confidentiality, but you should be able to get that.
Okay. Oh, that actually would be,
How long do pots soak for?
let's say like a day or two, something like that.
Now,
Longer in some, well, there's a
golden.
proposal.
Right.
Well, that's because they have strings and they leave them out there, but the long soak times I think are over 2 days, 48 hours. And there's a theory that is kind of being tested that the longer you leave a pot out to soak, the more self-sorting it does. So I think some vessels are soaking longer than others.
Do the pots also pick up other animals?
Yeah. And so I get that mostly through observer data. I only know about the crab that they catch, but at least I get some portion.
What did we see? We saw cod.
There's cod, yellowfin soles, they get like sculpin.
Can they sell it or do they avoid it?
But we require to discard it if I had to guess.
Yeah. And vice versa.
Is it a pain in, like, do they like, would that then lead them to avoid it or would they just be like, just throw it off?
What do
I
you do?
I don't think there's any other, the biggest bycatch that gets people to move in the snow crab fishery is sublegal snow crab.
Yeah,
So it's not any other species.
I think that as long as they're catching good male-sized crabs, they're
As long as the cod.
Well, I think there are sometimes permits where if they catch cod in their pots, they then use this hanging bait. But I don't know the details for how that works.
I want to think a little bit more about this multiple response thing.
Yeah, we
Let's-
talked about it a little bit before. I tried, I did throw out using the maximum area where they put their effort in.
Because it's like a multinomial trial with what you're doing is if you have two observations in a week, you're saying that you're modeling it as two multinomial trials. So I think makes sense, although they can't be independent. Because if you're over there, your next one isn't going to be hyperspace away. So this might be one of those things where it's probably best maybe to use the first data point for the week,
Okay,
and that will get rid of the independence problem.
makes sense.
The first data point of the
So in other words, if you've got 3 shots during the week, right, because they can't be independent, right, which of course you're assuming for all these
Yeah.
data, using the first one shouldn't be biased, you would think.
Do you have that though?
You know, the
Yeah,
day.
oh, actually, I don't know which one's first.
Yeah.
You just have,
You just have,
Yeah.
you just,
at the week they visited these sites, they don't say when they visited which.
I mean, maybe I can figure out which one's like the farthest away from the port. I don't know.
Or you can randomly select.
That's true.
What you don't want to do is create bias.
Mm-hmm.
I mean, how many of these things do you have? What proportion of multiple shots in a week? Multiple locations in a week?
I'll say 60%.
60
Yeah, most of the fishing trips
involve
have been
multiple.
most of the fishing weeks,
Yeah.
all multiple areas, yeah. That's why I think
Getting the raw data.
getting the raw data really.
Talk to Ben Daly.
So I'm showing results for the best fitting model. This is the fleet-wide area preference. So lighter color is more area preference. This doesn't really show us anything new. It kind of just confirms what we know.
Wait, so darker is least?
Yeah. So people like to hang around west of these Off Islands, southeast here. Yeah, this is not all that new. We just plotted fishing.
Just the distribution.
But
This is catch distribution or effort distribution?
So this should just be the average of the data.
yeah. Maybe accounting for those co-variables.
Right.
Okay.
And this is across years and across weeks.
Yeah. Post 2006.
Yeah.
Post fractionalization.
And this is through last year,
Up to 2020. Yeah.
2020.
2020.
I have a funny feeling 2021.
Yeah.
Might have been over the.
Yeah, this might get a little bit more attention.
Yeah.
So these are the parameter values, sort of the positive to negative effect size. Positive means it's attractive, negative is the opposite. First up on the very left, we have tradition. It seems to be very important. Crabbers like to fish where they've gone in the past. And we have CPE at the vessel. That makes sense. They like to stick to where they've also been successful. In the
Sorry,
past.
remind me what tradition was where they.
Where the proportion of fishing in that area has 2 weeks.
Like in the past 2 weeks.
Well,
Not in past years.
No.
So they tend to stay where they were.
Yeah.
That's what that's at. All things being equal, they don't want to.
Yeah, they have their kind of like favorite general regions that they stick to.
I mean, that's sort of related to cost of travel as well. I mean,
Yeah.
those two are going to be correlated.
Okay. And then we have CPU with the fleet. That's pretty important. This is interesting. I think this shows that people are paying attention to what other people are catching and where. And then other effort kind of gets at the same thing as number of pots dropped by other vessels. Also pretty high. Then we get to sorting. Those error bars are quite large, but that's probably because of that. 30% only observer coverage, but still nice that it's a positive sign. And then moving on to the negative ones, there's risk of the fleet and risk of the vessel. Those aren't very desirable. You don't want large swings in your catch. Ice, this makes sense.
Surprised that it's that small an effect, because
Yeah.
if it's ice, you would expect that you don't go there, but apparently you do.
Yeah, I thought it'd be like super binary. It's like can or cannot go. I mean, there is some kind of fuzziness with the ice data. Like they categorize ice with like thick ice or like slush ice. So they would discretize that kind of data. And then survey. This one's a little bit surprising. I'm not super concerned with it though, because the survey is conducted like half a year before the fishery actually starts, and there's a whole bunch of genetic migration, especially with the male crabs.
So does that say that, which I think makes sense, because most of the biomass is on the shelf during the survey, because the shelf survey, right?
Mm-hmm.
Whereas the catch is closer to the slope.
Yeah, so I guess they go.
So if all things being equal, you would expect that where the survey found animals isn't where you would expect fishery to be.
Yeah.
So I think it makes sense,
Okay.
but I'm not.
That makes sense.
Yeah, I wouldn't. Not sure. In some sort of sense of model selection, common sense removal method.
Yeah.
Yeah.
Oh, I was going to say, Jim has a question. What does the survey value mean here?
Survey value. This is just the density of commercial size males they caught in the survey. I think I had like a 100-mile radius.
Okay.
Fragrance cell.
Sorry. She said Andre answered him.
And then finally, our biggest effect size. This is distance support. This matter a lot. And all in all, this kind of confirms the general commercial fishing strategy. You want to maximize the revenue or CPE while
And these are all
minimizing costs.
fixed effects.
Yeah, so this is for all of the fleet. And then I think maybe specific to the crab fishery, they tend to be a little conservative in where they fish with the tradition parameter. And then there seems to be some great deal of information sharing with those fleet-wide metrics like CPE or risk and other efforts.
Well, and all your covariates are z-score, right?
Are these? No.
Okay, so you need to be careful how you interpret these parameters then, right? Because they're units of it.
Oh, I do. This is effect size, so I was standardizing by their. After I get those parameters,
Okay.
I standardize them by their standard deviation. Does that still get too much?
No.
Not enough? Okay.
I don't think so. I tend to z-score when I'm working.
Yeah.
Vicky, that's what you're doing as well. You're z-scoring.
Yeah, because, I mean, what units is the distance to port in?
Exactly.
Yeah.
Is it kilometers?
Yeah.
So 0.6 doesn't really make it, I mean, 0.6 times 5,000 is, well, what would be 5,000? Yeah, so definitely think about Z-score.
Yeah. Do they all deliver to the same port?
No,
Some deliver to the bridge, right?
there's St. Paul, there's Dutch Harbor,
And Acton. Yeah. Acton, Dutch Harbor, pretty similar, but.
Yeah.
But yeah, so
But
so that suggests the ones that deliver to St. Paul are probably more likely to fish farther north, right?
Yeah, I mean, we'll get into it. We'll
Yeah,
have some
okay,
figures.
okay.
We'll see, yeah.
yeah, I think standardized will help because then you'll get a sense of 1 unit of standard error, basically.
Okay.
So that's how I tend to think of these things. Is how much the CPE, how much does the utility go down with 1 unit of whatever it is, one standard deviation?
Yeah. Then okay, so we dividing by the standard deviation to get effect size, that doesn't do anything. Just skip that step altogether.
What did you do with the mean?
No, I just used the parameter values divided by the standard deviation.
By the uncertainty.
Yeah.
I think
Yeah, no. So we're doing this.
Okay, moving on to the vessel diversity. This is, so imagine all the area preference intercepts, but that map for every single one of the vessels. And then there's some magic clustering algorithms. They tell me 3 is the optimal number of clusters.
So you only got random effects on vessel area.
No, I also have random slopes, but this slide is just on the random slopes. Yeah. So if I break them out into 3 clusters, they kind of shuffle pretty well between these broad geographic categories. The green means that they prefer that area especially more than already wide preference. The red is just they avoid. So there's this northwest cluster with 27 vessels. The middle is the southeast cluster, the smallest cluster with 23 vessels, and then finally the biggest one just west of the Crips with 56 vessels. And maybe their preferences are not as strong because of the lighter shading and color. And this is the random slopes that came out in the best model. So I oversimplified those cluster maps in the previous slide to this like green, red, blue. Green is northwest, red is west, blue is southeast. And then those random slopes, I added the fixed slopes and then just added some other bars into them. And so the 6 random slopes that came out of the best model, this is the top left is congestion or number of other pods struck by other vessels. I don't see a very big difference amongst those 3 clusters. In this top middle, that's CPE of the fleet. Maybe the northwest clusters pay for
How did you get the variances? What are they?
variances? That is the standard error of those random slopes within that cluster.
The standard error, okay, so this is not an uncertainty measure, it's a variability measure within the cluster.
Yeah, so the northwest cluster, maybe they pay attention more to the fleet-wide CPE relative to the other 2 clusters. Risk of the CPE with vessel, there's no difference. Bottom left, ice, I would have expected maybe the northwest cluster to be more tolerant of ice and because they're more exposed to it and have a less negative ice slope, but doesn't really seem to be the case. All the vessels seem to not like ice, and then the bottom, middle, that's probably the biggest difference with northwest having kind of a positive value for the distance to port. That could almost be like if you interpret at face value, yes, they prefer fishing areas far away from their ports. And then finally on the bottom right tradition, northwest vessels don't tend to fish where they fished in the past. Seems like that northwest strategy is really pay attention to what other people have caught, where not so much focus on their individual strategy and fish farther away from port.
Yeah, I think thinking about the scale will be getting these things scaled together. So,
Yeah.
like one is minus 0.003
Mhm.
and the other is 0.2, and without knowing what I'm comparing with, it's sort of hard.
Yeah. I think I didn't get that just in time for the estimation. But yeah, that's my goal here. I think something this model can't tell us about is like, do you have for each of this decision-making criteria, is this like an innate ability or characteristic, and you choose the area that conforms to your spatial strategy, or do you choose the area based on those area attributes that defines your decision-making criteria? It's like kind of chicken versus the egg. I'm leaning more on the latter, where you choose to fish really defines your decision-making criteria. Does that make sense?
Well, what we're looking for is what causes, if you want to say that, where people went, right?
Mm-hmm.
So we're saying these are the factors that lead to the outcome you've observed.
Mm-hmm.
Right?
Mm-hmm.
So essentially you can make a prediction from this rather than inference. So you're talking about what are the given where people go, what are the properties of that spot as opposed to what led to the spot. I think what we're trying to do is what led to the spot.
Yeah, I see. Okay.
Actually, I was sort of thinking about this, and I have a question. I mean, in terms of diagnostics, have you thought of doing sort of a cross-validation where you fit the model to n-1 years and predict the year that you didn't get to? That would be probably a better test than just the best data.
Yeah, I think so. Yeah, I should do that.
Because none of these variables depend on year, correct?
Depend on your.
They're all depending on vessel and area, but not year.
Yeah.
So yeah, you could fit the model to n-, obviously the best model. Don't fit everything, but fit the best model to leave out 1 year, fit to the rest, predict the year that you didn't fit to.
Mm-hmm. Okay. And then how about like port of landing? Is that's I guess I already have that data.
Yeah, they know what they port of landing.
Okay, that makes sense. And this, I want to look at this diversity over time.
Ooh,
so it's just this sticky plot. The x-axis is the seasons, and the y-axis is the popularity of fishing that geographic region. So they're not really broken down by vessels, or they are broken down by vessels, but they're fluid in time. And the lines that crisscross from like green to red or red to red, that's just how many vessels are switching over to that geographic area for that season. First glance, like blue, you see that's diminishing. This is not all that new. You know that crabs are just more prevalent in the north, so there's no reason to fish in the southeast. Something else. Oh, there's a lot of switching going on. It seems that they're pretty adaptive from like the individual vessel perspective, and they're able to just follow the distribution of crab depending on where they are. So they're adaptive, which is.
So how does this relate to your earlier figure that showed the 3 clusters?
This, so each of the colors here correspond to those characters.
Okay, so this is the first one were clustered vessels, whereas this is vessels in a cluster.
Vessels predominantly fish in that area. So, maybe I should use it slightly different color scheme for this.
What year did you initially cluster it on?
I clustered it on the vessels, and so.
Oh, so like all years?
Yeah.
So vessels cluster may change from year to year, obviously.
Mm-hmm. Yeah.
Okay.
But these are vessel area interactions, right? That you clustered on, and they don't depend on you.
Yeah. No, they do not.
So the original cluster is just vessel area being clustered. Whereas this is how many vessels went to these specific spots.
Yeah.
And some.
Oh.
So the one is, basically one is actually fleet dynamics, which is there are vessels that have this pattern, whereas this says, given an area, how many people went there,
Exactly, yeah.
which is, it's just a slightly different concept.
So this is just the distribution of effort.
This is the distribution of effort by little colored boxes.
Yeah.
Which preferably shouldn't have the same colors as the
Yeah,
other.
yeah, I should probably do that.
It'd be interesting if like there was vessels, if you looked at the vessels that don't change areas
Yeah,
year
yeah.
to year.
Actually, that is an interesting question.
I think there's quite a contingent of red that stays red.
Yeah, like what's up with those vessels?
Yeah, and are the vessels that don't switch, do they just leave for that season and come back?
But if you go back to the original vessel area interactions, all the clusters are represented in all the areas, right?
Yeah,
So
Yeah.
there's no, this wouldn't say to me that there is too many vessels that only go to the, southeast, for example.
no,
or
yeah.
But
in cluster 2. Unless some of those red boxes mean 0.
Yeah, I mean, I guess the model still has to spit out the area intercept for every vessel.
Yeah, but it could be pretty low. I mean,
Yeah,
it could be
yeah.
minus 998 or something.
Those variables, were they z-scored when you clustered on them?
These,
These
no, but they came out pretty following a normal distribution.
yeah, well, there's a variance, obviously, but they're random effect. So
Okay, these are the
mean
random
0
effects.
and standard deviation something.
Okay.
And with clustering, I don't think it matters what the variance is because it's a cluster of the values.
No, it's, yeah.
Wait, so what are these clusters made of? What's going into this and what's doing this?
So these are the random intercepts per vessel and then just clustering.
So each vessel has an area effect.
Got it.
On top of the fleet effect.
Yeah, across all the years.
Yeah, yes, there's no year effect anywhere in this model, which is good because you like predictions.
Yeah.
It would be good not to have a year effect.
Trevor has a question about, I guess, the snake diagram.
Yeah.
He says there are blue squares inside of the green square areas.
Yeah,
So from here, this plot, I just assigned the area to the cluster or the vessel cluster at the highest value. So it's not perfect.
Yeah, I mean, if I was going to produce this, I would probably be a little more discreet. I was wondering if I was seeing blue.
Yeah.
Trevor would like to also continue talking.
Oh, yeah.
Trevor, can you speak?
Yeah, so I was trying to, can you hear me okay?
Yes.
I was trying to, because the problem with some of the blue areas being inside of the green areas is that then when you interpret that vessel diversity plot going left to right, you're not sure if they're moving from green to blue. Which blue are they moving between? Are they moving between the lower right blue or the upper left blue, which is really green? So it's a little bit confusing.
Yeah, that's true. Yeah, this one's a little sloppy, but I think next time I'll just hard code those lines, and that'll help with kind of separating this plot or these clusters versus the vessel cluster.
Would those lines be lat long or lat or long or diagonal?
I think I would still follow the general shape of these vessel clusters.
There must be a way to cluster the random effects in a way that ends up with discrete chunks, basically. I don't know what you're looking for a 2D cluster, basically. I'm sure those.
Yeah.
Jim, do you have thoughts?
Jim knows the answer.
Yeah, if it's okay, just to understand this a little bit more, sorry to add on, but the leftmost blue, green, and red bars, those are the original categorization, the clustering of the vessels. So I'm a little surprised if that's true, number one, that I would have expected more boats to be in the blue cluster than the green and red, but not knowing anything about the fishery, but just seeing closest to port, there would be more boats in that.
What's clustering
I actually don't remember. Some
Like-
R package.
HCA or something like
Ham
that.
or whatever they are. There's a whole
Yeah.
bunch of them.
Yeah.
Do you have like a mix of like quantitative and categorical ones in there? Like, is the ice one a quantitative variable that you can?
Well,
have
these are.
Oh, these are all the random effects.
Random
Yeah, yeah, like.
But I was thinking about that, like, vessel size.
I've done some clustering with like the combo ones, if you want to talk about
Okay,
that.
yeah, that'd be
later.
helpful, I think. I was thinking about it, I forget for which question within this project, but, yeah, probably.
Sorry, I interrupted Jim, I think.
Jim, did you want to?
No, I think I understand it, but as long as the leftmost blue, green, and red are the boats that are in the initial cluster. Is that correct?
No, these are just purely vessels that were in those blue, red, green in particular weeks or particular years.
Okay, so it's across all the years. Yeah. Okay, thanks.
I mean, basically, all vessels move between spatial areas, and the cluster is found across the entire space, just with different concentrations.
Mhm. Yeah.
There is nothing discrete about these, which makes sense.
Okay, so some concluding takeaways from a fleet-wide perspective, this is quite a conservative fishery spatially. There seems to be a lot of information sharing that's probably facilitated by the rationalization program, and new conditions, and also co-ops. All the crabbers are involved in a co-op, and co-ops have been modernized over time too. So probably more exchanges or more cahoots with each other.
Do you know whether, I think we talked about this in the proposal, but the vessel, do you know anything about the vessels in the clusters?
In the clusters?
Yeah, so in other words, the actual random effects clusters.
Oh, like size.
Yeah, is there anything that distinguishes, if you're one of the guys who goes to top, the northwest, is that because your boat is bigger, because you're in a particular co-op?
Yeah.
Because you're a TV star? I don't know.
Yeah, that's true. Yeah. I can search that up. I do remember discussing about it.
Yeah, you talked about in the proposal, was that, is there a predictor of which cluster a vessel will be in? And
yeah, I think we came out of that discussion saying, oh, well, the crab vessel out of the Bering Sea, they're probably all well equipped to weather whatever conditions. But I think that was interesting. I think that might go into clustering in different categories.
Yeah, if you've got covariance, that
You do have vessel attributes.
Yeah.
I can find it. I know where to find it online.
But I mean, so these are not randomized vessel numbers. These are. So
yeah, I know the names.
You know the names. So
There's we're working on like a clustering thing on West Coast bottom trawl surf crab fish boats, and those are a bit more diverse. But we've been doing some stuff that like says it kind of depends what you're clustering on, like. Even clustering on like vessel attributes versus like EDC data is going to put people into different, or vessels into different clusters.
Yeah.
So it's kind of,
it's like a pretty subjective process. I have a lot of like drawing the lines.
Well, no, I think the cluster, I mean, I talked to Emily about different clustering algorithms, but I think the idea of clustering on the random effects makes sense to me.
Yeah.
Because that's saying, given everything else that these guys are dealing with, why do some go north and some go south? And, I don't know what the silhouette size is that, distinguishes these clusters. So normally you look at the silhouette and see how different are these clusters.
you could do like I think sometimes they do like the linear discriminant analysis too to like, it's like another diagnostic.
So and that's all part of the I can't remember which package it is, but it's cool. Because I think that's the most interesting thing, is that these sort of behavioral clusters in the fishing. And then of course the fixed effect is interesting as well. But yeah.
Yeah. So the diversity, I think it it's a good sign that they're adaptive, but it still does not prevent a bad tack closing of the fishery. Honestly,
It's pretty out of control of the fleet.
Yeah. Oh, good. Well, you can go to Russia.
That's Andre.
No. Well, depends. It's the OFL to do it.
Question, Terrance, just, it's like, I don't wanna, this be out of the scope of your project or the goal of this model, but have you considered taking like the green centers of distribution from the summer survey? Cause that definitely has changed over time for snow crab. And if you look at the northwestern area, like, to the west of St. Matt's, that was far out of the historic fishing grounds for snow crab.
Yeah.
And that was pretty novel. And I think part of the reason people went up there was that there wasn't much sea ice, and also the survey results of the survey the previous year, because there was no survey in 2020.
Yeah.
2020 kind of pointed that snow crab were moving in a northward distribution, and so people were up there because they weren't finding crab in historic grounds.
Yeah.
Although that's a year you didn't use, right?
I did have 1 year that the first year they were very low.
Oh, okay. So off the collapse.
Yeah.
Because you're talking off the collapse, right?
Well, I'm thinking like if you take the NIC survey data and you just look at the mean center of distribution of snow crab through each year, I mean, that would be, I mean.
Well, that's sort of in the
Wow.
survey,
That's the.
in the survey
Yeah.
last year, but I mean, the big change in the distribution, that's recent, right?
Yeah.
So that's not in your data set because you didn't use 21, 22.
No, I do have 1 year where they went up really far north.
Right. Well, if you haven't got 20, I think it's 21, you haven't seen far north.
Oh, really?
They did. That was a very funky year.
It was rough.
Yeah. They were fishing pretty much on a slope, right?
Yeah.
It was, your model will not predict that year.
Yeah. Okay.
But in his 2020, at least showing like the clusters of the fleets, there was more in the green, which points to the fleet moving in that kind of northwest direction. And you probably with new data, you see that persists and continues.
Yeah.
That's why I'm keen on seeing that sort of cross-validation where you leave out a data set and predict where, if you've got really funky years that the model can't predict, you'll see that.
Yeah.
You should see that.
Probably.
Yeah, so
Interesting to see that.
your 27%, is that like 100% in some years and 0 in others, basically?
Yeah. That'd be interesting to see which areas they mostly get right. I'm sure the more popular areas.
Yeah, well, I mean, I mean, as you pointed out earlier, I mean, these models essentially start with an area effect. So basically you're saying, my best estimate of where people are going is just take the historical distribution, divide the number of fish shots by N, and that's really what that global average is, roughly speaking. And what you're trying to do is do better than that.
There's this applications. This would feed well into a spatial MSE, which Baptiste is working on. So a lot of the interactions between crabs and crabbers. This would predicting where the weekly fishing distribution would be quite handy, and then maybe some advice to management. I mean, this is nothing new to them. Like, there's probably going to be losses in the southern areas. The plants say like, there's a whole bunch of crab up north. Why would you make your deliveries all the way down south? Of course, there's designated shares, but the product quality degrades, making that long trek down south.
Has anyone ever done transshipment of the crab fishery?
Transshipment.
What about taking the product and loading it onto a separate vessel that would take it back to Dutch, for instance?
Oh, like this.
Yeah,
Like tendering, but on an oceanic scale.
Yeah.
I don't know much about that, but that seems like a definite possibility.
Is anyone still doing floating processing, or these all?
Yeah, they do their stationary floating processing. I'm talking to Brian Coverhouse about it. It represents such a small portion.
Yeah, but in the Dutch, St. Paul's is a small facility.
Yeah.
And so if crab comes back and it's farther north, either that's going to have to expand that facility, or they're going to have to find a way to get it back to Dutch and Yucatan without what's the travel time from the northern fishing grounds to, gosh, it must be 2 or 3 days, right?
I think it's around there. Yeah, for those floating stationary processors, I just assume like a constant, I don't know, put a pretty arbitrary low distance to get there, but I just don't have any good data to base it off of.
How many crab processors, within the processor allocation? How many are there?
Like actual plants?
Yeah.
I think that many. I don't know exactly. I'm gonna guess like 5 to 6.
That should be in the econ safe somewhere.
Yeah.
Brian will know that.
Yeah. Well, I'm sure that's in the safe.
But as we know, everyone reads the safe really carefully. The econ safe is a huge document.
Yeah.
Not a lot of pictures, lots of tables.
Next steps, hoping to set up some skipper interviews with Corey from the Skipper Sea Crabbers. Hoping that he actually sent that email out, CCing me this week. Really, I think a good question as well. All the questions that you asked, and also like, well, do you confirm or deny these results?
That's probably not the way I would express that.
No. Yeah, I'm trying to get at
It should be, where did I go wrong?
That's a little.
A much better question.
Yeah.
Tell me what I've done wrong.
Yeah, that's a better question.
And it must be sitting around on their hands, right? I mean, they're, it's not as if they're all out fishing. Although some of them are still out there.
Corey's busy. Bering Sea Crabbers have got, they're really busy. That's my sense.
Yeah. Well, I'm thinking skippers.
Yeah, a few of them are talking to the council.
Politics.
There was a voluntary fleet reduction in 2021. So originally all the boats were going to go out and fight over the small tag. And I think they had only a portion of the fleet go out. So I don't know how.
They share it by co-op structure.
Yeah, I don't know how specifically they came to that decision, but they did get there.
Yeah, herring fleets have done that.
Okay. Yeah, hopefully I'm on the right track at least.
Yeah, no, this is looking good. It's just, get the paper out. I like that one.
Yeah, that was for you.
What's the time scale for that?
Yeah, I feel like there's
Not
only
yet.
4 points. That's gonna add some time.
0.5 standard deviation.
Ron, how's your paper going?
Attention's going.
I'm looking around the room. The attention is on everybody, except Matisse. Oh, wait, we've got to finish that other paper with Maxine. He's working on it.
Yeah, I feel like the final message is unchiseled and then nice.
Yeah, I do think that you if you haven't done it yet, but just seeing, is there anything out there on other crab fishery effort models? I'm thinking the Norwegians would be probably something. I don't know really much about, what do they call those things? Norwegian lobster. Neprons.
Neprons, yeah. Norway lobster.
Yeah, so there may be something on it, because what you're looking for is a fishery for a crustacean in a broad area, whereas most of what Ray and I do are rock lobsters in New Zealand and Australia, where there is no, the dimension of the problem is very different. Whereas here, the choices aren't they're quite restricted. But what you're looking for is a fishery for invertebrates in a sort of a shelf area, which, thinking about it, the Norwegian, the Barents Sea area would come to mind.
How about the Atlantic Sea Scout?
Yeah.
Is there any reason to think that the things that motivate location choice for crabbers are any different?
Well, this is my question. Is what do we, as you now get to a point where you've got hypotheses, thinking about, what's the sort of, what have other people found, assuming they did it correctly?
Just thinking of fisheries I know, take the pollock fishery, there, bycatch of salmon, a salmon is a major constraint on the area of choice. If you take the West Coast bottom trawl fishery, it's by, particularly during rebuilding plans, or just bycatch of really highly quota limited species. This fishery doesn't really have that historically.
I don't think most invertebrate fisheries do, except, I mean, scallops obviously have those big closures.
Yeah. Trap fisheries are very keen and grab thieves.
Well, apart from whales.
Well,
And these guys have been known to get a couple of cetaceans.
isn't that right?
Recently.
Not recently. You don't need to get many.
No, I've heard more about golden king crabs and coral crabs.
Yeah.
That's been a hot topic recently.
In the traps.
And that is the loss of the big fish.
Yeah, they like land on the coral.
Oh,
break up.
yeah.
They-
Yeah.
Okay.
Surveys cause fishery collapses. That's my next one. All the crab fisheries with surveys are down the toilet. All the ones based on CPUE are in good shape. Sorry?
Crap, okay.
Yeah.
And now that Tyler has it, we'll see if the trend continues. That was a running joke. He was as an author.
Yeah, never do
See what
that.
happens.
Yeah, all the stocks with big surveys. Not in good shape. So it's the survey.
It's a survey around the drain, and that's along the bottom.
Yeah, yeah.
So it does it.
I can't remember, we can write a paper for Nature.
So no, we'd have to have a global map to get it into.
Yeah, that's true. Anyway.
Are there any questions online? Give them a few minutes.
Yeah.
Increase, get this paper out to 14 point font.
That's probably more than 14.
Yeah, that's okay, well, that's good.
Yeah, thanks for all the feedback.
And in 2 weeks' time, it's Kristen, I think.
No,
No,
next week is Albie and then
Next week, my diary is so screwed up.
We got.
we were a little.
I don't know.
Albie has always been next week.
Okay.
And
Not
then
according to my diary.
No,
Albie's, yeah,
this week is an off.
this is an off week. But Albie's always been next week.
So your diary's always been off.
Yeah. I'm in the dentist chair again. As far as I'm working, that's my purpose in life, is to keep my dentist golf habits going. He likes golf. He currently golfs 2 days a week.
Who?
My dentist.
Well,
That's a classic
dentists don't
activity.
work 5 days.
No, they don't.
I used to go running with a guy.
Thank you, everyone online, for coming. We'll be back next week.
He said, I said, "Any dentist work 5 days a week?" He says, yes, but I don't